AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 3: Data Preprocessing. Data preprocessing. Essential step to prepare data for mining. Involves data wrangling, cleaning, modifying, restructuring. Data preprocessing is the second of the 5 major steps in data mining. Welcome to Lesson 3-4, Normalizing Data. In this lesson, we'll explore what normalization means, why it's useful, and how to calculate Z-scores to make fair comparisons across different types of data. By the end of this lesson, you will be able to understand what normalization means, explain what a Z-score is and how to calculate it, know why Z-scores help compare data on different scales, recognize when to use normalization in data analysis, and know that Z-scores apply only to quantitative data. What is normalization? Normalization is the process of transforming data to a standard scale or distribution. It adjusts data so that it can be compared fairly, even if the original measurements were on different units or ranges. In a standard normal distribution, the mean is 0 and the standard deviation is 1. This allows you to see how far each data point is from the average, in standardized terms. What is a Z-score? A Z-score tells you how many standard deviations a data point is from the mean. It makes data independent of its original measurement units. For example, if you have height measured in inches and weight measured in pounds, Z-scores let you compare them on the same relative scale. This helps you understand which values are unusually high or low, regardless of their original scale. Calculating Z-scores. The formula for a Z-score is simple. Z equals x minus mu divided by sigma. In other words, take the data point minus the mean, and divide by the standard deviation. Here, x is the data point, mu is the mean, and sigma is the standard deviation. Let's look at an example. Imagine a test score of 85, with a mean of 75 and a standard deviation of 10. We plug those into the formula. Z equals 85 minus 75 divided by 10, which equals 1. That means the test score is 1 standard deviation above the mean. Interpreting the Z-score. A Z-score of 0 means the value is exactly average. A Z-score of 1 means it's 1 standard deviation above the mean. A Z-score of -1 means it's 1 standard deviation below the mean. Values around plus or minus 2 or 3 are considered extreme or outliers. Important notes. Z-scores only apply to quantitative data. That means data that can be measured numerically, such as height, weight, temperature, or income. They can be used for both continuous and discrete quantitative variables. Most software tools, including R, Python, Excel, and statistical packages, can calculate Z-scores automatically. When to use normalization. Normalization is useful when you want to compare data that comes from different scales. For example, comparing exam scores from 2 tests with different maximum points, or comparing sales across regions with different population sizes. It's also important when using distance-based methods, like clustering or nearest neighbor algorithms, where scale differences can distort results. However, avoid normalization if you need to keep the original measurement units for interpretation, such as when reporting descriptive statistics or summaries for a report. To sum up, normalization converts data into a common scale using Z-scores, allowing fair comparison across variables. It's a fundamental step when your goal is to make different data sources comparable or to prepare for advanced statistical analysis. That concludes Lesson 3-4, Normalizing Data. Remember, The book and supplemental resources are available online at Data Analytics Curriculum's website.